Welcome back to another BJC past paper review. Today we're going to review another health science paper. And so we're doing health science, and this is a paper 2 from the year 2014. Please remember again, whenever you're doing this examination, always write a school number, write a candidate number, write your initials and your surname. Please read through the instructions carefully before you start the examination and follow all the directives given by the examiner. The booklet should not be open until you are told to do so. So let's jump into question number 1. For question number 1, you see the diagram shows the human body cavities and the main organs present in them. And so let's quickly label. This is the cranial cavity, which is A. This is the cranial cavity. All right, and B, it is the thoracic cavity. All right. And then we have C, which is the abdominal cavity. All right, so the abdominal cavity is C. So we have those 3 cavities there. All right, so now let's go to the first question. For part A, it said name the body cavities represented by the letter A and B. All right, so A again is the cranial, and B is the thoracic. All right, so great. Now, once we have this, now we can now jump on to the next part of the question. All right, so here it says name one organ protected by each of the following bones. So the cranium is the skull. So what organ is protected by the skull is the brain. Let's put the brain right here. Okay, great. And the ribs protect the lungs and also the heart. So I'm going to say heart here. And I'm also going to put lungs as well. You only ask for one, but I'm going to put heart as well. So again, in the examination, if you should see a question like this, you know what to do. Or if they ask for more than one, they know exactly what to write. Now for part C1, it said name the muscle which separate cavity B from cavity C. And so what muscle is separating B from C? So the thoracic cavity and the abdominal cavity, what separate them is what they call the diaphragm. Okay, so let's go into the diaphragm. So there's a diaphragm. All right, so great. Now we say, how does the upward movement of the muscle named in 1 affects the lungs? So in other words, when the diaphragm goes up, how does it affect the lungs? And it is simple by decreasing. So what happened here? Let me go to the end. So it said, so what is happening here? So it decreases the volume of the lungs. So decreases the volume of the lungs. All right, and push your out, right? All right, decreasing the volume of the lung and pushes air out of the lungs. Okay, so I just want to put that extra piece right there, out of the lungs. All right, so great. So it creates an upward force, upward push, and that upward push in the lungs will cause the air to expel from the lungs. That is exhalation. All right, so it's exactly what is happening right there. And for part 3, in part 3, I'm just going to create a little bit of space right here so we are able to see properly. All right, so just a moment. Okay, that should be perfectly fine. Oh, excellent. All right, so here now it said that place an X on the diagram to show the location of the lungs in the body. So let's put where the lungs is located. All right, and remember you have 2 lungs left on the right, so therefore I could put an X on this side. That's where the lungs will be, or I could put an X right here as well. Okay, an X right there. So those 2 parts where the lungs will locate, but they only want 1 X, so we can put it on either side, really don't matter. All right, so let's now go into the next part of the question. And it said, which cavity contains the organs where bile is produced? And bile is produced by the liver. And so the liver is in the abdominal cavity. So this will be abdominal. So remember that bile is produced by the liver, but it's stored in the gallbladder. All right, so that's the abdominal cavity for the liver. And then kidneys are located where? And kidneys are also located also at the abdominal cavity. All right, so great. Messages are interpreted, and messages are interpreted in the brain. So that's the cranial cavity. All right, great. So now jump on to the next question. This question is question number 2. So the diagrams show the 3 types of muscles tissue found in the human body. And so you have muscle A, B, and C. All right, so here there's a complete table by filling in the blanks to show the name of each muscle, type of muscle, and then the type of muscle should be voluntary or involuntary, and example of organs they are found in. All right, so what I could do, I could quickly actually name them up top here for you, and then we go back down to identify them. So this is a cardiac muscle. A is cardiac, okay? So A is cardiac. B will be smooth muscle. All right, and just to know how they are arranged. So once you see these big spaces between the muscle, generally once you see them, you know that's a cardiac muscle, right? And then the smooth muscles, notice the shape of them. All right, and then these now will be our skeletal muscle, okay? All right, so those are the 3 muscles right there. So let's go down the table now to fill out the table. And so right here said that A, the name of the muscle, so this is cardiac, as we have it up there, cardiac muscle. All right, and then it's a type of muscle, and again, cardiac muscle, you don't control cardiac muscle, so they are involuntary muscle, right? So the type of muscle right here is involuntary. All right, again, you do not have control over them. Where do you find cardiac muscle? Again, in the heart. All right, so the heart is made up of cardiac muscle. That's why if you have an heart attack, they says cardiac arrest, cardiac muscle in the heart, cardiac arrest. All right, great. Now for B, in B now, the type of muscle in B is smooth, that we already established that. And then the type of muscle here, again, you do not control smooth muscle, so these are involuntary muscle. All right, so involuntary muscle. And where do you find involuntary muscle? You may find smooth muscle particularly. You may find them in the stomach, you may find them in the small intestine, and so on. So stomach, for example. You may also find it in the intestine. I said just to name a few places, but they are found. They can be found in many places all over the body, and especially those places that you do not control. All right, so good. Now for part B, it said muscle C is attached to bones of skeleton, right? So let's go back to muscle C. We know what muscle C is, and it's a skeleton muscle, right? So it's connected to bones of skeleton, and this is a giveaway because skeletal muscle they are connected to bones, right? That's why I call it skeletal muscle, because they're connected to the skeleton system. Now we said name the type of tissue found at the end of muscle C. First thing I want to point out that tendons connect muscle to bones. So the end of a skeletal muscle, what you'll more likely find is a tendon, because tendon connects muscle to bones. So this will be a tendon. All right. All right, great. So tendons are found there. Okay. All right. All right, so great. And then now, just some point before we go any further, there's a other structure called ligament, but ligaments, they connect bones to bones. Okay. So you can make a note of that. Ligaments connect bone to bone, but tendons now connect the muscle to the bone. All right. Now for part 2 of B, it said the muscle at C allow you to bend and straighten your arm. What must happen to these muscles to allow these actions to occur? So to bend and straighten your arm, what type of action is taking place by the muscle. If you think about moving your arm up and down, you realize that one muscle becoming longer, one becomes shorter, and those are the bicep and tricep muscles. So what must take place? The muscle must contract, and they also do what? Relax. So contract and relax. So these muscles must contract and they must relax. All right, and so as one is contracting, the other one is relaxing, right? And the term that describes muscles that work together like that, while one is contracting and the other one is relaxing, it is antagonistic muscles. All right, so how many muscles are found in the human body? This will be an approximate number, so I'm going to tell you, I'm going to give you 650 as a number, but the truth is it could be more than 600. So I'm going to put here that more than 600 bone, okay? Muscles, more than 600. All right, so great. So more than 600 muscles are found within the human body. All right, but question number 3, and we're halfway through it. All right, so this question now, so the diagram shows some glands in the human endocrine system, and we have done a question similar to this, but this one's a little bit different to show that the questions can be similar at times. And so Q will be what they call the pituitary gland. Okay. So this is the pituitary gland. And then this one that is not labeled in the throat, we talked about it in our previous paper. And this is the thyroid gland. So this is a thyroid gland right here. It's not labeled, but that is fine. R is on top of the kidney, so this is the adrenal gland. This is adrenal gland. And S is the pancreas. I'm going to leave it right here. Okay, so pancreas. And T, this is the female part, so this will be here. It's inside the body, so definitely is a female endocrine gland. And so this is the ovary. All right, so let's go down a little bit. All right, here they have a next part, which is U. So they put both male and female on the one diagram. So this one represents the testis. Again, just to point it out right here, testes is the plural form for both of them, right? So testes represent 2. This is a plural form. So testis is only 1. All right, so let's go down further now to see what's happening here. It's a name the organ R, and the organ R here, it is the adrenal gland. Okay, so the name of the organ R is adrenal gland. All right, adrenal gland. All right, but I am weary of this word organ because the adrenal gland is on top of the kidney. So R is on top of the kidney, but you pointed to the adrenal gland, so we keep it as adrenal gland. I'm not sure if the line is on the outside though, and so you have to be careful. I guess when you see the original paper, you know exactly where the line is. So you see 2 lines maybe. So if there's 2 separated lines and this is on the outside, then it would be the kidney, okay? Because adrenal gland, they are found on top of the kidney. But I'm assuming right now, based on the picture, that this is on the black spot. So if it's on the darker spot, it is the adrenal gland. If it's down further, then it will be the kidney. But since they say organ, you can just consider this to be the kidney, okay? All right, so great. But the gland that I'm pointing to right here, R is pointing to the gland, which is adrenal gland. All right, so let's go down to the next question. I just want to make sure I clarify those simple things for you. So when you go into exam, you know exactly how to approach your questions, right? All right, for part B, is to complete the table by writing the letter, name and hormone in the blank space. All right, you know what I'm going to do right here? Let's go back to this question, right? Because since they say organ, I want to make sure I don't want to mislead you or you have the wrong information here. So I'm going to use this as organ. So again, I'm going to change the gland and write instead, I'm going to put here the kidney because it stated organ, not a gland. Okay, so it's 2 different things. All right, so let's put the kidney right here as a gland. And again, the adrenal gland is on top of the kidney. All right, just to make a point right there. All right, so here now is a complete table by writing the letter, name, and hormone in the blank spaces. So the pituitary gland, right, is the name of the gland itself. And so what letter represent this? So go back to the diagram, we're going to see what letter represent the pituitary gland. And the pituitary gland is by Q, so we're going to put Q there. Okay, so Q is our letter. Okay. All right, so Q is our letter. All right. Now T, they want us to name that gland. So I'm going to go up to the name of that gland, T, and T is the ovary. Okay, so we'll go back and label our ovary. All right, and ovary produces estrogen, pituitary gland produces growth hormones, and the S is a pancreas, and pancreas produces insulin. Okay, all right. And for part C now, it's a name the body system which transport hormones around the body, and hormones are transported in the blood. So in the system that transport this is a circulatory system. Okay. All right, and just to make a note right here, right, that hormones are produced in one part of the body, but they have the effect in another part of the body. Okay, that's also important for you to note as well. So if the ovaries produce hormone, the hormones will not work in the ovaries, they will work inside of the uterus, for example, right? So they work in a different place. All right, so for part D1, it's a name the deficiency disease that will occur as a result of a lack of mineral iodine in the diet, and the deficiency disease right here is called goiter. Okay, and so how does this deficiency disease affect the human body? And what happened here is that it will cause a swelling of the thyroid gland. Okay, all right, so it causes a swelling, all right, of the thyroid gland. All right, so excellent. All right, so now, so again, once you have goiter, you see a swelling under the neck, all right, or the base of the neck. All right, and so for part E now, we say Mary, a 12-year-old female, is developing breast and growing pubic hair. It said, what name is given to this stage of development in her life? And this is puberty. All right. And it's a state another change that may occur in her body during this time. And so what may happen here is that she sort of produces eggs. So production of eggs. The production of eggs. Also, what could also happen again? Let me give you a next one. Our hips will be widened. Okay, so we'd have wider hips as well. Okay, and the purpose of wider hips is just in case she becomes pregnant, her pelvic area could accommodate pregnancy. Okay, or the development of the fetus. All right. All right, so part F is a name the hormone which would cause a boy to be able to jump a very high fence when being chased by an angry dog. And so you're going to produce a lot of energy to be able to run. And so the adrenaline is that hormone that will cause him to produce a great burst of energy. Also, his heart rate will increase to pump more oxygen to the cells to produce more energy as well, and also glucose. So the adrenaline will be that hormone. All right, so next question on the list, which is question number 4. All right, and so the diagram represents the excretory system in humans. And so this diagram, now let's just go through them real quickly. And so here we have, this is a kidney right here. Let's label this real quick. All right, I know you have seen this a lot of time. And so this will be the ureter. All right, and we have the urinary bladder. All right, so the urinary bladder is right here. And then if we go a little further, you're going to see the urethra. So here would be the urethra. Let me leave it from here, right here. Okay, great. So those are the different parts that make up the urinary system as shown on this diagram. So it said, A, complete the table which shows the parts and the functions of this system. And so what part makes urine? And we know that is the kidney. The kidney is responsible to make the urine. Okay, so this is the kidneys. All right, so great. Now ureter. The purpose of the ureter is to transport urine to the urinary bladder. Okay, So right here, I'm going to say, let's see if I could fit this real nice. Now we're going to be on that line, okay. So the purpose of this is to transport urine to the urinary bladder, okay. That's a function of the ureter. Now, the function of a bladder, let me just kind of adjust this a little bit to create some space. Okay, let's see if I could create some space here. All right, so make this a little bit better. Excellent. Okay, great. So now I'm going to put on now, the function of a bladder is to store urine. So stores urine. Okay, great. And now number 4 is it carries urine to the outside of the body, and urethra does this. So urethra is the last tube that will take urine to the outside of the body. All right, so great. Now continuing here, it said name the main nitrogenous waste. The nitrogenous waste expelled in urine, and say where it is made. So the nitrogenous waste that they're talking about here, it is urea. All right, and urea is made in the liver by a process called deamination. So it's made in the liver, okay? It said, how would the urethra be different if the diagram showed that of a male instead of a female? So what it's showing is a female. Let's go back to the diagram to see exactly what is happening here. So now they're asking now, this structure right here, which is a urethra, right? This piece is a urethra. So how is a urethra different in a male compared to a female? So this is a female right here. So they're actually asking, you know, how this becomes different in a male than if it's a female. Now, one thing you can notice here, right? Let me just kind of point out real quick for you, is that if it was a male, then the penis will extend outside, right? So the penis will come all the way down here, and the penis will be on the outside. And so therefore, the urethra will continue all the way to the outside. So the urethra will be much longer, right? So the length of it will be longer if this was a male, because it extends to the outside of the body into the penis. All right, so let's answer that part of the question there. So the urethra, it will be longer, okay? So it is longer, all right? It would be longer. And why the urethra is longer? Simply because it extends into the penis. All right, I'm going to make a note right here. It extend into the penis. All right, and the penis is on the outside of the body, yeah? All right, so that's why it's longer. Okay, just in case you need to explain why it's longer, that's the reason behind it. Now, describe one change you may observe if the urine of a person was dehydrated. So if a person is dehydrated, what would be the color? What would be the changes or in that person's urine? And so for a person who is dehydrated, then the urine will become dark yellow. So it becomes darker. Okay, so it becomes darker, or I'm going to put in here dark yellow. So it could be dark yellow. All right. All right, great. Or a bright yellow, you may want to say. So you're going to see you're going to be really, really deep yellow color in it, right? So part A of this question, it says state two ways blood in the renal artery is different from blood in the renal vein. Now let's stick a pin right here, right? The renal artery, just remember this, renal artery will take blood to the kidneys, while the renal vein is the vein taking blood away from the kidney. Let's just talk about this. Let's go back to the diagram to assist us in this, right? Let me show you exactly what I'm talking about. I'm going to put one blood vessel on this side and it going in. This is the renal artery, okay? So the renal artery going in, and let me put another on this side, which is the renal vein. As a matter of fact, the renal vein will connect to both, and the renal artery connect to both, but I just want to make a point right here. This is the renal vein going out. Now, I want to think about the kidneys, yeah? What is happening inside of the kidneys? The kidneys are making urine by taking away urea, salt, and water from the blood, and that will expel out of the body in the form of urine. So the blood that going to the kidneys must contain more salts, more urea, and more water, because those are the things that make up urine. The blood that is leaving the kidneys now must contain less of these things, because they are taken out of the blood to make urine. All right, so let's put our answers in now. So here, there are three major differences. They only ask for two, but I'm going to put all three for you, just in case you may need them. And so right here, again, we're going to say in the renal artery, which is taking blood to the kidneys, you'll find more urea. So let's stick with urea first, right? And so the renal vein must contain less urea. All right, and notice we're comparing the same things. So please also make sure to do that again. Do not mix up your points all over the place. Make sure if you're comparing urea, compare urea. Okay, and next thing that what the blood is going to will have more salts. All right, and the blood that leaving the kidneys now will have less salts. All right, great. And another one here again is water. There are more differences though, but I want to zoom in on these three because these three are the major substances involved in when blood is being filtered and urine is formed. Okay, and so here you have more water going. And so because urine is formed, you'll have less water coming out of the kidneys, okay? So let's say less water. All right, so great. Now we have the three differences, right? They only ask for two, but that is great. We finish with this question now. We're going on to question number 5. So we're almost there. One more question to go after this. And so this, the diagram shows a section of the human skin. And here we have a structure, call it X. And we know this is the oil gland, otherwise called a sebaceous gland. All right, let me just label a few things for you real quick, yeah? So this is the oil gland. All right, otherwise called a sebaceous gland. All right, so that's the sebaceous gland as well. And this gland right here is called the sweat gland. Okay, so this is a sweat gland here. And then going up will be the sweat duct. So that tube that going up to the surface of the skin is called the sweat duct. All right, and then the opening where the sweat duct ends is called the sweat pore. Okay, so this will be the sweat pore. All right, that's opening, or the space is sweat pore. These here will be our nerve endings. So we have nerve endings right here. Okay, so these are nerve endings. All right, so those are just some basic features inside of the skin. The uppermost surface of the skin is called epidermis. Then you have a dermis, and then you have the subcutaneous layer, right, or the adipose tissue, which is a fat layer below the surface of the skin. All right, and so right here now, part A now, so completed the paragraph using the words listed below. And so you have here, you have sebaceous, you have epidermis, you have capillaries, you have dermis, you have sweat, you have adipose. And so the skin is divided into two main layers. The outer waterproof layer is called the epidermis, and then the dermis would be in the middle portion. So this will be epidermis right here. All right. And it's a with the underneath. So what is underneath is the dermis, as we talk about that. So this is the dermis underneath the epidermis. Okay, so this will be dermis. All right, and it's the lower layer contains what type of follicle? And that is hair follicle. Okay, so the hair follicle will be in the lower layer. And then now it's a tiny blood vessels called capillaries. All right, so capillaries are tiny blood vessels. All right, and dash gland. So what gland will be in here? It is the sebaceous gland. Okay, so what they call the sebaceous gland. All right, and so the sebaceous gland is the oil gland, but it's attached to the side of the hair. Okay. All right, so the sebaceous gland. So that complete that paragraph right there. All right, so now it's the albinos have white hair and pink eyes. Name the pigment lacking in their skin, and this is melanin. All right, and now we said state the function of this pigment, and the function of this pigment is to protect the skin. Okay, to protect, I will say protect the body generally, to protect the body from UV rays, which is ultraviolet rays. Okay, all right, let's say UV radiation. Right, that's the purpose of it, to protect the body from ultraviolet radiation. All right, so great. Now, moving on here, part C now, we said the skin is one of the sense organs. So it's one of the sense organs. It's a name to stimuli the skin detects. So what can the skin detect? The skin can detect temperature. The skin can detect pain or touch. So I'm going to put pain or touch on this side. Okay, so pain or touch. All right, so great. And then for part D now, is to state the function of structure X on the diagram. So structure X, what is structure X again? Let me go back to it. Structure X. Okay, so structure X is the sebaceous gland or the oil gland, and it asks you to state the function of structure S on the diagram. So looking for the function, and so the function here will be to produce oil or sebum. So it makes the skin moist to produce oil or sebum, okay, to moisten the skin. Okay. All right, so moisten the skin and make the skin also supple. Okay, to moisten the skin and also make the skin supple as well. All right, so you don't be drying out and all that, all right? Okay, great. All right, so next question here, which is the last question. And write this question now, asks, you know, the diagram shows the front view of the human eye. And we have three parts right here. This part here is called, this is R. So R here is the sclera. All right. And then now we have also here, now we have P, which is, all right, so this I'm trying to figure out, okay, right. So this, I'm going to kind of identify this two ways for you. The central part is not so clear. Let me kind of make a line, so it's going to be a little bit better, okay? So Q is pointing to the internal part right there. I'm putting a line there to separate it so you can see the difference is not so clear on this diagram. And then outside of Q now will be P, all right? And so here now we want to name these, so name the parts P, Q, and R. And so Q will be the pupil. That's the more central part of the eye right there. And then surrounding the pupil, we have to call it iris. So this will be the iris. All right, so again, we can name them on the lines as well. So again, P is the iris, Q is the pupil, and R is the sclera. All right. All right, so great. Now, the next part of the question right here now, we said, which labeled structure controls the amount of light entering the eye, and the labeled structure that is control the amount of light going in. I'm going to explain this for you right now. It is the iris, so it is structure P. Now, how structure P controls the amount of light into the eye, right? When it controls the size of a pupil, okay? So the iris controls the size of a pupil. The pupil is not a structure. It's just a space between the iris. It's an opening between the iris. So when the iris relaxes, which get longer, the pupil gets smaller. So when the pupil dilate, which means getting wider, is because the iris is contracting, okay? And so remember now, when you're in bright light, the pupil is smaller, which means it constricts. And when you're in dim light, the pupil dilates to get more light into the eye so you can see better. All right, just to make a note of that. All right, so let's go to this. So which label structure? We say structure P, and this is called the iris. All right, so it's the iris. So I'm going to just make a note of that. So it is the iris, but it asks for which label structure, so it's P. And also want to make a note right here, just to help you out a bit. If you go in exam, you should see this. So the iris controls, all right, the size of the pupil. Okay. So the iris controls the size of a pupil, all right. And by doing so, the iris will control the amount of light entering the eye. All right, so for part 2, it's what change takes place at structure Q when bright light is shown directly into the eye. So here we have bright light. So if bright light taking place, what happened to Q? Then it becomes constricted. It becomes smaller. okay, it becomes narrow. Okay, so any of those answers could work. So I'm going to put them right here. So the pupil will get smaller by constricting. So you're going to constrict. All right, so you can also put the word, besides saying constrict, you can also put the word, let's go back a little bit. So constrict, you can also put, let me put a number of words right here. So it could be constrict, it could become narrow. So become narrow, all right? Or you can say become smaller, okay? All right, so any of these will actually work for it. Anyone will actually work, okay? All right, just to point that out as well. And let's move it a little bit more. There's some space there. All right, so great. All right, just a little bit up. Excellent. All right, so yeah. All right, so now let's jump to the next part of the question, right? Because we're almost out of here. All right, we're almost out of here. Almost. All right, and so for this question, we say diagram Y was, diagram Y shows a common eye defect. Diagram Z is incomplete. So the diagram on the right is incomplete. The diagram on the Y is showing an eye effect. And it's a name. So the first part of the question is name this eye defect shown in diagram Y. But I'm going to show you something real quick, right? Right here with the rays met, they are meeting in front of the retina. So in other words, the rays fall short. Just think about the rays fall short, right? So the rays fall short, it therefore means that this is short-sightedness. The rays are not long enough to reach the retina, right? And so short-sightedness is when the rays meet in front of the retina. Therefore, mean the image is not formed on the retina, it's formed in front of the retina. And for farsightedness is when the rays will form or meet behind the retina. So it's long behind the retina, if you think about it in that way. And so we can identify short-sightedness and long-sightedness simply by where the rays are meeting. So this is short-sightedness. Short-sightedness is also called myopia. All right, so myopia is another word for short-sightedness. All right, so next part is to give one symptom of this eye defect. So if you have short-sightedness, you're unable to see distant object, okay? So the symptoms, you're unable to see distant object or unable to see properly, okay? Or unable to see distant object properly. All right, let's say distant objects properly. All right, because you may see them but not so clearly, right? You may see a blur when looking at distant object. All right, so part 3, it said complete diagram Z to show how this eye defect can be corrected. And so short-sightedness is corrected by what they call a concave lens. So a concave lens now, what we'll do is spread out the light rays some more and let them form onto the retina. So the concave lens is shaped something like this. All right, I'm going to draw, okay, that's not the perfect thing, but it will work for now. What I'm going to do is to draw the rays of light to show exactly how they will go. So they go in through the lens, all right, and of course they're going to diffract into the eye and go straight onto the retina. So another ray will come in again, some diffraction will take place, go in again, this diffract, and it will form onto the retina. So both of them will meet onto the retina, okay? All right, you know what I'm going to do? I'm going to delete this to make it a little better. It's not so good the way I want it. All right, so I'm going to draw it a little bit better now. Hopefully I could catch a straight path. So go there, a little diffraction taking place there, refraction taking place, then it bends onto the retina. Okay, so the rays of light will refract once it go into the different objects. So refraction taking place, and then it goes right there. Okay, excellent, good. So that's what I want to show you. They will meet onto the retina. And so once they meet on the retina, the image will form on the retina and you can see properly. Again, this lens is a concave lens, otherwise called a diverging lens. So what we'll do is to cause these rays to spread out a little bit more, and so they will meet exactly onto the retina. So if you think about it, it can make perfect sense, right? If rays are diverging more, which means spread a little more, All right, just like that. I must put in two little small arrows. So these way will spread out a little bit more. So this gap already meet will eventually come onto the retina, right? But again, the optician will tell you, will fit different size glasses or different curvature of lens. So depends on how bad your sight is. Your curvature may change to make sure that diverging of the rays will meet onto the retina. All right, and that's why they test you for a period of time. Now, part D, last question, and we're out for real now. It said, name the structure in the eye which carries nerve impulse to the brain, and this is called the optical nerves. All right, and this is the last thing for today. All right, so we're out of here. We're finished. Please do well on the examination. All right, and I will see you in the future for more reviews, for more lessons. So whenever you're ready, jump over. But for now, be safe. Take care.